Hello, I'm Dmitry, head of this laboratory, and today we will show you how we make nanomaterials by using chemical vapor deposition. Let's see what we have here. Let me introduce my colleague, Konstantin, who will show you all details of this procedure later. We have main component of this system is an electrical furnace, which can be heated up to 1700 centigrades. In addition to the furnace, we have pipelines for different gases depending on the chemistry of material we are going to prepare. And the last but not least, I look up here, we have a gas sensing system. In case of any leakage of these dangerous gases, the system will be automatically shut down. And yesterday we made a try to make boron nitride nanomaterials here. You can see different components of this: precursor, silicon wafers, and after the synthesis, the wafer changed the color. It means we are successful in making nanomaterial made of boron nitride. And Konstantin will guide you for the rest of the procedures.
Hello everyone! Our first step is preparation of powder mixture. For this synthesis we will use 0.5 grams of magnesium oxide, 9 grams of boron and 2 grams of boric acid. First of all, we need to measure the weight of powders. For this we need to weigh this glass first, re-zero its weight and add our powders to the glass. Then we transfer it here. Now when we have our powders ready, we can mix them a bit and then transfer to the ceramic bowl. I do carefully and try to distribute powder uniformly in the bowl. Now when it's ready, we can put our substrate, silicon wafer, in another bowl. And this is the actual place where our nanostructure will be grown. So now when our stuff is ready, we can transfer it to the furnace. This board needs to be put in the zone with the highest temperature. For this we use this stick with a centimeters mark and put it inside on the length of 75 centimeters. You need to do it carefully to be sure that the board not fall down. And now when this part is ready, we can transfer our powder mixture inside. And this powder mixture needs to be put it on zone with lower temperature. So we put it inside only for 40 centimeters. Now our furnace is ready to be sealed. First of all, we use this thermal radiation shield. It's a very important part because it prevents our end seals from overheating. We put it inside and then use this end seals and close this one. Now we close second end of the furnace and put again these thermal radiation shields. Very important part to prevent our end seal from overheating. And everything is ready for closing. Just check that our O-ring is clean and sitting well, and then we can close it. Now when the furnace is closed, we can turn on the vacuum pump. Here it is. It's important to do it slowly to prevent spilling of our. You can see over here on this meter that pressure is going down, and once it's ready we can start heating. Now when the furnace is heating, we can turn on our gas lines. Now when we have vacuum in our furnace, we can turn on argon flow and fill the furnace with argon. We are checking the flow using this meter and gradually increase the flow speed. You can see it slowly goes up, and once it will be 1 atmosphere, we can open this valve and flow through the furnace will going on. When we're going close to the zero, it's better to reduce flow a bit to be more careful. Now we have atmospheric pressure inside our furnace, and we can open this valve, and you can see bubbling through this oil. It means we have actual flow through our furnace. Now we can open ammonia line. I set ammonia flow here, and now we have both gases going through our furnace. So once the temperature will reach 1300 degrees, reaction will start.
When the temperature inside the furnace at the low T-zone reaches 700 degrees, the powder mixture starts to produce a reactive vapour. This vapour travels through the furnace to the high T-zone where the temperature is 1300 degrees. Here, the vapour reacts with the ammonia gas by breaking the nitrogen-hydrogen bonds in ammonia and boron-oxygen bonds in boric acid. Boron atoms and nitrogen atoms then recombine to produce a boron nitrate nanostructure, which is deposited on the silicon substrate as you can see in these examples.
Now when our powders was heated up to 1300 degrees and stayed at this temperature about 1 hour, and after this it was cooled down, whole procedure took about 10 hours, we can turn off the furnace and open it. First I open this end, unscrew this part, take end seal out, and take this radiation shield from the furnace. Now we can open second part. Again unscrew. Taking off end seal and second radiation shield. Now we can take our samples from the furnace. We need to do it carefully because it's very easy to spill the powder. First bolt we just do like this, and second one we push through the furnace to the other side. Now we can take sample from the furnace. So now our sample is ready and we can see the results. So first of all, powder mixture, it changed its color a lot from the black one to the gray and white one, and its color changed different bits because this both was a temperature gradient zone. This end temperature was 800 degrees and here we had 1200 degrees, and it's clear that at 1200 degrees the reaction is more intense. And if we look on our silicon substrate, you can see that its color changed a lot compared to the initial silicon wafer, and it means that we have nanostructured coating on its surface. So now our experiment is finished, and I hope it was interesting and I understand a lot about basics of CVD synthesis.